concept of free expansion. For free expansion, we are looking at, say we have two vessels connected together by a valve and it's completely insulated. So we have it like this, two vessels. This vessel is completely insulated. Okay. Now, vessel 1 is initially filled with fluid at a certain pressure. Vessel 2 is evacuated, no fluid, is free of the fluid. Now, if valve A is opened, fluid 1 expands to fill vessel 2. Now, that will imply that the P1 initially pressure is going to be lower. P1 will be lower, that's the pressure in the vessel will be lower since it has flowed to fill vessel 2. That is, pressure in vessel 1 will be lower since it flowed to fill vessel 2. So it will be lower than the initial pressure that it had. Now, this concept is called free expansion or unresisted expansion, and it is a highly irreversible process due to the fluid undergoing eddy motion, undergoing eddy motion. Now we can apply the first law to the initial and the final state. So recall that Q comes as U2 minus U1 plus W. Now remember, this whole setup is insulated, so that push makes Q 0. Also remember that it is a non-flow process, so W remains 0. Now we have the term U2 minus U1, which equals 0 is equal to U2 minus U1 plus 0. This implies U2 minus U1 is equal to 0, and implies U2 is equal to U1. Also recall that for a perfect gas, U is equal to CVT, so I can write CVT1 is equal to CVT2. Okay, so if we have these two terms goes out, then we can state that T1 is equal to T2. So this expansion, this free expansion, states that for a perfect gas undergoing a free expansion, the initial temperature is equal to the final temperature. This holds for a perfect gas. For a perfect gas. Now, with this, we have looked at some basic concepts in thermodynamics. Let's see what we'll see in the next class. In our next